Good evening, everyone. My name is Valeria Garcia, and today I will be presenting my research project for Introduction to Sustainable Design titled Sustainable Design Approaches in Singapore. I hope you like it. By way of contextual selection, Singapore presents an extraordinary empirical case study for contemporary urban planning literature. Unlike conventional metropolitan regions that possess expansive rural hinterlands for resource extraction and waste absorption, Singapore is a sovereign, hyperdense island state facing severe physical boundaries. The rationale for selecting Singapore lies in its capacity to invert profound geographic vulnerabilities, such as spatial scarcity, zero natural hydrological reserves, and total energy import dependence into a benchmark framework for urban resilience through policy-driven engineering and biophilic spatial design. My presentation will evaluate Singapore's sustainability trajectory across three critical dimensions: the built environment, municipal water management, and circular economic integration. Hope you like this presentation. Dived in this investigation, we need to examine Singapore's baseline demographic and ecological profile. Occupying approximately 735 square kilometers in equatorial Southeast Asia, the island supports a population of roughly 6 million inhabitants, resulting in a human density exceeding 8,000 individuals per square kilometer. This structural density imposes immense stress on municipal infrastructure and terrestrial ecosystems. However, Singapore's natural vulnerabilities are firstly, the absolute absence of natural groundwater or major river networks, the pronounced susceptibility to urban heat islands effects due to dense concrete massing, and lastly, the existential threats posed by climate-induced sea level rise across its low-lying coastal topographies. In response to state governance established in Singapore Green Plan in 2030, this overarching policy framework transitions the municipal design paradigm for historical garden city beautification toward an engineered city in nature. This aims for carbon neutrality by mid-century through closed-loop utility integration and mandatory green building standards. For this research, I evaluated Singapore's strategy through three key modules of sustainable design. First, the sustainable built environment, looking at how high-density skyscrapers are engineered to reduce heat and energy consumption. The second is the water management, which explores how Singapore transformed its extreme water insecurity into full water independence. And third, but not least, the circular economy for sustainability, which examines how waste streams are captured and converted back into energy and resources. Now, let's move forward at the literature reviews about each of these three aspects. Firstly, the Module 3, Sustainable Built Environment, which will examine regulatory green building codes, thermodynamic optimization, and vertical biophilic integration. So, moving forward, the Sustainable Built Environment, Ziva Hope and Jane in 2017 evaluated the Singapore's green construction transformation through sectoral innovation system perspective. The authors of this research demonstrate how state regulatory instruments, specifically the Building and Construction Authority Mandatory Green Mark Certification Scheme, have optimized building performance. Implemented architectural interventions include high-efficiency HVAC systems, passive ventilation designs, high-performance thermal envelopes, and building-integrated photovoltaics. Quantifiable benefits include marked reductions in energy consumption per square meter across public housing, estate, and commercial high rises, yielding significant carbon abatement. However, the authors had identified critical implementation friction, retrofitting existing structural stock, presence, substantial capital expenditure challenges relative to greenfield developments. Furthermore, maintaining developer compliance amidst fluctuating material supply costs presents persistent administrative hurdles. An institutional study by the Center for Livable Cities in 2019 investigates physical urban design interventions intended to mitigate tropical microclimate degradation. Singapore actively mandates biophilic integration, enforcing high-rise sky terraces, vertical green facades, extensive rooftop canopy coverage, and high albedo reflective coatings. Thermodynamically, these vegetative facades mitigate solar radiation absorption, directly dampening the ambient urban heat island effect and reducing artificial mechanical cooling demands. Concurrently, vertical urban greenery restores localized ecological connectivity and air filtration. Conversely, the study emphasizes engineering limitations. Retaining heavy substrate mass and vegetated structures on elevated high rises creates ongoing structural load challenges and elevated long term structural maintenance costs. Furthermore, extreme equatorial storm events present risks on soil erosion and drainage saturation on high-rise installations. The second distinct sustainable design module that I would like to highlight was the one that we talked in Module 7, which is water management, which investigated closed-loop wastewater reclamation and urban stormwater catchments dynamics. Lee and Tian, back in 2016, analyzed Singapore's closed-loop reclaimed water framework, commercially designated as New Water. To bypass hydrological reliance on neighboring states, Singapore deployed advanced multivariate membrane purification technologies, specifically microfiltration, reverse osmosis, and ultraviolet irradiation, to process municipal wastewater into high purity water. This infrastructure currently satisfies up to 40% of national water demand, providing a climate resilient supply that insulates the state from drought. Industrially, New Water is prioritized for fabrication sectors, thereby reserving primary freshwater reservoirs for domestic consumptions. Lee and Tan noted two fundamental operational constraints. Sociologically, the initial deployment required extensive public relations efforts to overcome the psychological barrier associated with indirect potable reuse. Technically, high-pressure reserve osmosis filtration exhibits substantial electrical intensity, creating a direct operational trade-off between water security and national decarbonization goals. Expanding upon macro-scale water infrastructure by Tortajada back in 2006 evaluates Singapore's 4 national TAPS governance model. To optimize surface water capture, urban planners converted approximately 2/3 of the nation's global terrestrial footprint into an engineered catchment network. Stormwater runoff is captured via concrete conveyance channels, urban canals, and estuarine reservoirs. This dual-purpose design prevents urban inundation while securing millions of gallons of potable water, simultaneously establishing urban blue spaces for social utility. The primary challenge outlined by Tortajada centers on spatial allocation and contaminant mitigation because catchment boundaries coincide directly with dense commercial and residential land uses. Preventing non-point source pollution requires stringent environmental monitoring, continuous challenge maintenance, and costly runoff filtration systems. For the last distinct sustainable design module, I chose module 12, which was circular economy for sustainability, which analyzes industrial symbiosis, waste to energy recovery, and material upcycling frameworks. LASCO in 2024 assesses the systemic execution of Singapore's Towards Zero Waste Master Plan, instituted to extend the lifespan of Semakau, the nation's sole offshore landfill. Singapore's circular framework relies on mandatory commercial food waste segregation, extended producer responsibility for electronic waste, and advanced high-temperature waste-to-energy incineration. Incineration reduces unrecyclable solid waste volume by over 90% while exporting thermal electricity directly to the national grid. Furthermore, incinerated bottom ash is processed into an aggregate building material termed new sand, diverting solid waste from oceanic disposal. Despite these advanced industrial loops, Velasco highlighted persistent public-level systemic barriers. Residential recycling rates remain depressed due to the convenience of high-rise chute disposal systems, leading to high municipal waste stream contamination that hinders downstream sorting efficiency. The industrial frontier, Resvanigami, Khosravi, and Ramakrishna in 2021 investigated cross-sectoral industrial symbiosis through the Tuas Nexus facility. This project co-locates an integrated waste management facility directly alongside the Tuas water reclamation plant to achieve closed-loop energetic and material synergies. Thermal energy derived from solid waste incineration generates high-pressure steam to power water reclamation machinery. Simultaneously, organic food waste is co-digested with municipal sewage sludge, exponentially increasing anaerobic biogas yields for electricity generation. This spatial collocation drastically maximizes land utilization and cuts overall life cycle carbon emissions. However, the authors emphasized that executing such a complex cross-agency industrial symbiosis involves an extreme capital costs, complex thermodynamic engineering, and administrative coordination challenges between separate utility authorities. To conclude, I would like to bring again that Singapore provides three essential scholarly insights for urban sustainability literature. Firstly, the high urban density is not only an inherent barrier to sustainability. Under the integrated master planning, the density enables high infrastructure efficiency. Secondly, converting linear waste streams into closed-loop inputs, as shown in water reclamation and industrial symbiosis, is important for resource-constrained cities. Lastly, top-down regulatory instruments are crucial for incentivizing private sector compliance with green design metrics. And now I am showing you in this slide the formal peer-reviewed and institutional references that supported this research. Thank you so much for your time and attention, and I hope you have an amazing summer.